Hello, I'm back. Let's finish this example. So we already found the area of the sector, which was about 18.8. Now we want to figure out the area of the triangle. And we were at 1/2 times 6, which was the base, times 3 times the square root of 3. 3 times 3, square root 3. So for the area of that triangle, we should get about 7.8 rounded to the 10th. Okay, so now to figure out the area of one of these sectors, just one of them. Okay, so this is just for one of these red sectors that I'm coloring in right now. We're going to take this, segment, not sector. We're going to take the sector minus the triangle to get the area of one of the segments. So 18.8 minus 7.8. So the area of one of these, and I know this is a rounded answer, so rounded to the 10th would be about 11.0. Okay, but now we have 3 of those. Okay, so we are going to take that 11.0 times 3, because there are 3 of those segments, right? There's this one and this one too. So that would give us about 33.0 square units. So that's the area of the shaded region. Got it? The second part of this now says to find the probability of that shaded region. All right, so in order to do that, we need to figure out the area of the circle, don't we? We already figured out the shaded region, but now we got to figure out the total circle so that we can figure out the probability. So the area of that circle is going to be pi times 6 squared, because that's going to be the radius is 6. So pi times 6 squared, when you round it, and we actually did this one in the previous one, I think we had a radius of 6 in one of them, was about 13.1. Okay, so the probability of the shaded region, you take the area of the shaded region, which was about 33, divided by the area of the entire figure, which in this case was a circle again. So 33 divided by 113.1, we get about 0.29 for that answer. All right. So that's what you're going to be doing today. You're going to have some that are going to be just some general geometric probability. You're going to have a couple where you're going to have to find the sector or the pi piece. And then you're going to have just a few where you will be asked to figure out the area of a segment or several segments. Now, one final note before you have time to work on your worksheet for today. What you may have noticed with this final example here is that technically this is just a circle with a hexagon in the middle. So people always ask, every year someone asks, well, can I just figure out the area of the whole circle, then figure out the area of the hexagon, then subtract that, which would give all of these little, parts here, and then just divide it by, in this case, divide it by 6, to get one of these? Well, sure, you could. All right, so that's just another way. So if you notice that on here, yes, you can do it that way. If you prefer to do it the way that I just showed you, then please do it that way. If you do it correctly, either way will give you the same answer. Okay, so that's just another way that you can do it, and some people just prefer to do it that way because we did spend a lot of time with that in 11-3. Okay, so for the rest of the time today, you can work on your worksheet from 11-5. And what I've done is I've posted the solutions to that online for you so that you can check your work, in a math lab or after school when you're at home, what have you. Okay, so please use that resource today. And that way I've worked out the problems so you can kind of see my steps as well. So use that resource to help you through this, and I will see you all tomorrow for our Cornell review. Have a great day.